Hello and welcome back to Wooden Data Center. Today I want to introduce you to the HPC data center we designed for tender. But the solution ended up being so good to me and my partners that we want to promote this even further and throughout through to our industry customer, because we were able to design a relatively compact and well-functioning concept for HPC that is high-performance computing, whereas the compute part, the chips that do the heavy lifting, that they are actually water-cooled, direct-to-chip water-cooled, in a very interesting temperature range. Between the cold water being 45 degrees and the hot water being 62 degrees, which is ideal not only to reuse the heat later onwards, for example for heating offices or to move the heat into processes, but this is also ideal for most European locations to create a cooling solution that is very, very efficient, because anywhere in Europe you usually throughout the year are able to cool down the water without having to generate artificial cooling in terms of electrical or adiabatic in terms of evaporating water. So you only move the outside air through the cooler and are always able to create the cooling you need, making this very, very efficient. Let me talk you through some of the features on the outside, and then go into the bit of the inside arrangement. So the space requirements were quite limited. This is why this looks like such a compact factor. These are 4 20-foot ISO containers, 3 of them joined together here as the white space for the IT, and the 4th container is actually holding the dry cooler, a large massive dry cooler. We're talking about totally 750 to up to 800 kilowatts of cooling gear, and this is achieved in a relatively compact space, because due to liquid cooling you have very, very high energy density per rack. This is up to 84 kilowatts per rack. As you can see, we have 8 ComputeRacks that have a dummy inside here. This is the piping connecting the servers with the direct water cooling and moving then the water temperatures into the raised floor. This needs a raised floor not to move the air, but rather to have space for the piping. Sorry for my rough piping explanation. I'm working to create nice curved shapes in the future. I've just been able to get myself into to this space and to producing neater piping in the future. But for now, this needs to be enough. So the energy is transferred down into the piping and then into the dry cooler, with having an outside dry cooler pump box that is protected and with a redundant pump setup, and then moved into the dry cooler and moved outside to the air. The whole setup, if you look on this from the top, has an IT space with the raised floor and a technical room with the main distribution, the fire extinguisher system, and connection to the outside world, to the fiber. There is, however, this is displayed here with the empty racks. These usually would be full, but these are air-cooled storage and admin racks. all the storage components that we looked into this, and most of the storage components we are looked into, they are still air-cooled. And the air cooling we achieve with using these direct free cooling aggregates, the maximum capacity we would need 3 of those, but they are actually enabling that all residual heat that is not captured with the direct-to-chip water cooling systems, that the whole white space can be temperature stable with using direct free cooling equipment. Yeah, so far so good. We will also create another version that will be also able to incorporate immersion cooling. But this is a nice compact form factor with up to 750 kilowatts of power that we can, with a very efficient and cost-effective cooling solution. Feel free to reach out, modify, and if you have any questions, just happy to connect to you about this and talk about this on data centers.